Hey guys, so in this video, we're going to go through all the examples that are found in the sample space and the theoretical probability section of notes that you have. So let's just start going through it, right? Some of these you have gone through in class, but I wanted to make sure you had a video to go back on just in case you got lost on anything, okay? So in the first example, we have someone's taking a quiz. It is all true and false questions. And we want to figure out the probability of getting exactly 2 correct. Whereas there's 4 questions, we want 2 out of the 4. Now, first thing we're going to keep in mind is that there's 4 questions. So we have question 1, question 2, question 3, and question 4. They're all true and false. What happens to question 1 has no outcome on or the effect on question 2. So if I get question 1 right, doesn't mean I'm going to get question 2 right. And I have 2 choices. I have a true and a false. Or more importantly, I have a right and a wrong. So it's either going to be incorrect or it's going to be correct. Those are our 2 options here. So I have 2 options for question 1. I have 2 for 2, 2 for 3, and 2 for 4. So overall, I know I have 16 possibilities. So that's the first thing, trying to figure out how many possibilities there are that we have. From there, we're going to set up a sample space so we can then keep in mind, well, where are those 2 correct? All right. So one option is I could get everything correct, right? That would be the best point. So that's one option. I could get everything correct. That's the only way I can get everything correct. And I'm going to break down my sample space a little bit to make it easier for us to see. Another way is I get everything incorrect, right? Or wrong, however you want to look at it. Right? And then it's going to be kind of broken up from there. I could get 1 correct. Now, when I look at it this way, I'm going to think of each individual question. I could get question 1 correct and all the others wrong. I could get question 2 correct. I could get question 3 correct, or I can get question 4 correct, right? So that's one way of looking at it. I can look at it the other way of, well, what if I got only 1 wrong? So maybe I got the first one wrong and all the others incorrect. Or maybe I got the second one wrong and all the others correct. So forth and so on. Okay, and then the other option is, well, where are the 2 correct? Now, before I even start that, I want to figure out, well, how many do I have to come up with? 16 total, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 already laid out. So that means there's 6 possibilities I have for having 2 correct. So I could say, what if I get the first 2 correct? Right, that's one option. I can get the first one right and maybe the third one right. Or maybe the first and the last. That's one setup. I could maybe get just the second 2 correct. Or maybe the second and the fourth correct. Or I could lastly maybe just get the last 2 correct. And this should be 6 then. 1, 2, 3, 4, 5, 6 out of all of them. That adds up to my 16. So the question is, what is the probability of the student guessing exactly 2 correct answers? Well, that then falls under this category, right? This was my all correct or all wrong. 1 correct, 1 wrong, 2, right? So from here, I know there's 6 of those. And it's 6 out of the 16. So my probability of getting 2 correct is 6 out of 16. Now you can leave it like that with probability. You can reduce it if you wanted to, right? So 6/16 would be 3/8. You could even make it a percentage, which is 37.5%. Nice thing with probability, you could do it in any format you want to. Okay, next thing we're going to take a look at is our spinning wheel, right? So I have a spinner. I have yellow, blue, green, and yellow. No, yellow, blue, green, and red. And I have the spinner results. So first thing, let's talk theoretical. Theoretical means in theory, what should happen? Well, I have 4 equally spaced parts. That's important. They're all equally spaced. So that means it's a 1 in 4 chance for each color. Right now, if these were not equally spaced, that would be a different story. But because they're all equal sections, I know I can have 1/4 of my theoretical probability. So any color is 1/4. So the probability of red is 1/4 theoretically, probability of blue is 1/4, etc. So they want to figure out which of the experimental probabilities matches that. So let's take a look. So experimental wise is what we did. So we have the probability of red. Now we spun it 20 times. So that's the number of trials that goes in the denominator. And then whatever happens goes on top. So I have 5 out of 20 for red. For green, I have 9 out of 20. For blue is 3 out of 20, and so is yellow. So which of these comes out to be 1/4? And that ends up being red. So the probability of red matches our theoretical probability here. Okay. Next thing we're going to take a look at is our complements. So complements, just remember that the complement, A bar, is 1 minus P of A. So if I have an event that happened and I want to find out what's the opposite of that event, you just subtract it from 1 or 100% if they give you a percentage. Okay. So for number 4, these should be easy. You guys did this in class. It would be 0.55. For number 5 is 3/4. For number 6 is 0, right? If that's 100% happening, is 1, then 0. And then for number 7 is 0.97. Okay. And again, whatever they give it to you in, try to keep it in that format. So notice I didn't change the percents. I didn't change them to fractions. If it wasn't a fraction, I didn't change the fraction to a decimal when it wasn't a decimal. Okay. So those are your complements. Okay. Our next one. So we have a survey of 2,184 adults, 18 and over. 1,328 of them have at least one pet. We want to figure out types of pet owners have if there's a dog. Okay. So it's the probability of dog out of pet owners. And that's important because they gave us 2 totals. So one total is everybody. The second total is pet owners. So out of that 2,184, not everyone owns a pet. So I don't want to use that total. I want to use the 1,328. So the number of dog owners is 916 out of the total number of pet owners, which is 1,328. You can leave it like that, or I just tend to always change anything to a percentage most of the time. So 68.98% of pet owners own a dog. Now, one thing to bring up, if you actually add these together, it is going to be more than 1,328. And that is because 1,328 is at least one pet. Some of those, maybe they own a cat and a dog. Maybe they own a bird and a fish, or a bird and a cat. They might own multiple pets. Maybe they own all 4. So we don't want to include them duplicates. So we're only using the 1,328. Okay. And the last question is using some geometry, some geometric probability. So from here, first thing we want to take a look at, are you more likely to get 10 points or 0 points? Let's start there. 20 points or 5, and then any points or no points. So first thing, I'm going to expand this out. We're looking at a square. Area of a square is side squared. And we're looking at circles. Area of a circle is pi r squared. Okay. We're going to leave things in terms of pi until the very end when we do this. So first thing I'm going to do is find all of my areas on this side and then use it inside the problem. So each of these are 3 inches. That's what they're telling me. This is 3, this is 3, and this is 3. So the whole diameter is actually 18, right? Because the radius would be 9 then, if I have 3 sections of 3. So this is an 18 by 18 square. Where'd my pen go? There we go. So my outer level is the square, and its area is 18 squared, or 18 times 18, which is 324. That's the first thing I have to figure out. Then I'm going to find each individual piece. I'm going to start with the innermost and then work my way through from there. Okay, so the 10-point ring, that's simply a circle, and that circle is a radius of 3. So pi 3 squared, we're going to leave it as 9 pi for right now. Then we have the 5-point circle. So the 5-point circle, its area is going to be pi times 6 squared, because it's the second one out, but we have to subtract from that the 10-point circle. So minus pi times 3 squared. Okay, so 6 squared is 36, minus 9, so that would be 25 pi. We may need that, we may not. We'll find out. I'm going to move myself up here. Then we have our 2-point circle. So that area is pi times 9 squared minus the inner circles, which is just the 6 squared. We don't have to do 6 squared minus 3 squared because we're taking out that whole entire inner circle. So then we have 81 minus 36, and that's 45 pi. And then the last option is 0 points. So that's the square. So 18 squared, which we know what that is, minus the circles. So minus pi times 9 squared. We're going to leave this as 324 minus 81 pi. Okay, so that way when we do this, we'll just leave in the decimal form and subtract from there. So this is all the outside stuff we got to do in order to answer the questions. So part A, are you more likely to get 10 points or 0 points? So the probability of 10 points is its area, 9 pi, divided by the area of the whole thing. So that 324 is always going to be our bottom because that's my entire outer ring. So when we do that, 9 pi divided by 324, just put it in your calculator. You get 8.73%, or about that. Okay. The next one, the probability of 0 points, is now this 324 minus 81 pi all over 324. Again, just put it in your calculator. When you do that, please put the top in parentheses, so that way you calculate that first, and then it's going to divide it, and you're going to get about 21.46%. So you are more likely to get probability of 0 than anything else. Now, if you want to know how many times more likely, just as a side note, you would divide these two. So if I took 21.46 and divided it by 8.73, that's how many times more likely it is to happen. And that comes out to be 2.45 times more likely. Okay, so this is just a side note if they ask you that, because they could ask you how many times more likely. You just divide, because remember, division is undoing a multiplication that we had. So probability of getting a 0, 2.45%, 2.54 times more likely, and we can clearly see it as the higher percentage here. Okay, part B, now we're going to take a look at, that should be 10 points or 5 points. My bad. Can't get 20 points on here, right? So we already know our 10 points. 10 points is 8.73. So now we got to do the probability of 5 points, which again, I'm going to take that 25 pi divided by 324. And that's going to get me about 26.2%. So it is more likely to get 5 points than it is to get 10 points. And again, if I wanted to, I could figure out how many times more likely. I'm not going to do that because they really aren't asking us for this. And then part C, are you more likely to score any points or no points? So we already know the no points. The no points is 21.46%. So the probability to score any points, well, that's the complement of it. So I could take 100% and subtract 21.46 and get 78.54%, which makes it more likely for us to get points than it is to get no points. And again, that uses the complement, which we just talked about previously. So hopefully going through these with you helps you out a little bit. Obviously, any other questions, you know you can reach out.